Section 3 of the finance chapter is called Simple and Compound Interest. So in this section we introduce the idea of interest, and the idea is fairly straightforward. Simply stated, as it says here, the basic goal of business is to take a small pile of money and turn it into a big pile of money. So because of that, we expect that money will grow over time, so it's more valuable to hold money today than to hold the same amount of money later. Because if I hold it today, I can earn more money with it and ultimately end up with more, a bigger pile. So because of that time value, there's a value to holding money, and in order to pay for holding money, we pay interest. So if I want to take out a loan to start a business, I will pay the bank for the privilege of holding on to that money so that I can start my business and make more money. Similarly, if the bank wants my money to take and invest, then when I put my money into a savings account, the bank will pay me interest for being able to hold on to my money. So that's the idea behind time value. And so we'll talk about in this section present value versus future value. And that's simply this picture here, where we have the present value that is expected to grow to the future value. And it's expected to grow using this interest that we'll talk about. Before we go on, though, the simple vocabulary we'll need in this section is the principal, which is the amount of money that's borrowed. So if I take out a loan, that amount that I take out at the beginning is called the principal. Or if I put a bunch of money into a bank account, that amount I put in is called the principal. And then we have simple interest versus compound interest. Simple interest just tacks on a percentage of the principal. The compound interest, though, tacks on a percentage of whatever the current balance is, which is the principal plus the interest that's accumulated to this point. So simple interest just calculates interest based off of the principal. Compound interest also includes the accumulated interest to this point when it calculates interest. So for simple interest, we can calculate it here, but we'll go ahead and jump straight to the formula, where interest equals PRT. Of course, for compound interest, there's a different formula that calculates the interest, but that's the one for simple interest. And then, as we stated, we talk about future value, where the future value equals the present value, or the principal, times 1 plus R, the interest rate, times T, the number of years. So we can calculate either the future value if we're given a present value. So if I know how much money I have today, I can calculate what it'll get to in the future. Or we can work backwards, and given a future value, we can find a present value. And there are examples of both of those types of problems here. Here we find a future value given a present value, and then here if we're given a future value, we can find a present value. So we can work in both directions off of the same formula. And that will hold true as we go on and get other future value formulas later on. With compound interest, again, the idea is that over time, as I start with a certain balance, let's say in year 1, if I tack on some interest, now I have a larger balance at the end of that first year. Then, during the second year, interest is based off of that balance, which is the previous year's balance plus the interest that was earned. Right? Because simple interest ignores the interest that's earned. That doesn't enter into the calculation. But compound interest uses that and builds interest off of interest. And that's the idea behind compounding. So we can do this process, or we can get to a formula, which is this one right here, that relates the future value and present value for compound interest, similar to the simple interest one. And then we can do examples with that, doing the same kinds of things, where if we're given a present value, we can find a future value, or given a future value, we can find a present value. Either way. And we have examples of both of these here. Then there are a few other things to note. A quick example here that shows that you should avoid rounding and why you should avoid rounding. And then after that, we get into comparing interest rates. So basically, to compare two interest rates, all you have to do is think about how much each account will earn given the details of that account. So there's an example that does that. And based off of that, we talk about these three terms: the nominal interest rate, which is the interest rate that's stated on an account, and then the annual interest rate, which is similar to the nominal interest rate, it's just that it's the annual one. So if it's a monthly interest rate, You just multiply it by 12 to get the nominal annual rate. And then there's the effective rate. So as opposed to the nominal or the stated interest rate, the effective interest rate is what actually takes effect, what actually is used on this account. Basically, it's an interest rate that takes into account the effect of compounding. And so we go through an example here where we talk about how to calculate that APY, or the effective interest rate, based on a given account. And then we're given a formula that relates the two. If we know the nominal interest rate, we can figure out directly the APY, or the effective interest rate. And there's an example doing exactly that. Then we get to continuously compounded interest. Continuously compounded interest says if we compound interest more and more and more often, eventually we hit a certain limit, and the limit that we hit is based on this number E, which is roughly around 2.72. And so we get actually a simpler formula for continuously compounded interest. But it still relates present value to future value, and we can still either be given present value and asked for future value, or vice versa, be given future value and asked for present value. And then we have some examples of just that, being given present value and asked for future value, and then being given future value and asked for present value. Finally, we get to comparing different compounding periods. So we have an account, and we talk about what happens if this account is compounded annually, and then if it's compounded monthly, then if it's compounded daily, it gets compounded continuously. And all that changes for these first three is this value for n, and then for the fourth one we have a completely different formula because it's continuous compound interest. Then we have an example here where we talk about the amount of time it'll take us to double an investment. And this is a nice rule of thumb that people will use when comparing several investments, for instance, just to get an idea of how good an investment actually is. So here's a rule of thumb that you can use in calculating doubling time, just to quickly get a rough estimate. This isn't something that we'll do too much, but it's an interesting side note that we can make here. Then, in the same section, we talk about inflation. And the reason we do is that inflation really can be treated as a compound interest problem. And so here, that's exactly what we're doing, treating inflation as a compound interest problem. And then we can turn it around and talk about depreciating dollars. And here's a formula that we can talk about depreciating dollars, which is just sort of a different way of thinking of inflation. One way of thinking of inflation is that prices will rise from today to tomorrow. The other way is to think that $1 tomorrow will buy less than $1 today. Really, it's the same kind of statement, but it's just phrased in a different way. So we can either phrase it in terms of rising prices, or we can state it in terms of depreciating dollars. And then we mentioned the CPI here, finally, which is an index that keeps track of inflation by comparing prices on standard items over the years. And there's an example of calculating, or estimating rather, what a house would cost in one year given what it costs in another year, using the CPI to make that inflation estimate.